I welcome you all for this lecture series on deep learning. In this lecture, we will briefly discuss about baseline models in deep learning. We'll see one by one. So first we'll see the introduction to baseline models. The concepts of baseline models are the concepts of baseline models refers to the idea of starting any machine learning or deep learning project with the simplest possible prediction approach. Instead of immediately building complex models, we first create a basic reference model that sets the minimum level of performance expected from the system. This concept ensures that model development begins in a structured way, allowing researchers to understand the difficulty of the problem and the quality of the data set before applying advanced algorithms. And here, the role in machine learning and deep learning are in machine learning and deep learning, the baseline models play an important role because they act as a foundation for model comparison. They help determine whether a trained model is actually learning meaningful patterns from the data or simply producing results similar to random or trivial predictions. By establishing a benchmark performance, baseline models guide the selection of algorithms, feature engineering strategies, and network architecture in both traditional machine learning and modern deep learning workflows. Next, what is the importance of model evaluation is baseline models are highly important in model evaluation because evaluation metrics such as accuracy, loss, or error values cannot be interpreted properly without a reference point. A baseline provides this reference and allows researchers to measure real improvement achieved by trained models. It prevents overestimating model performance and ensures that uh, conclusions drawn from experiments are reliable and meaningful. Next, what is a baseline model? The baseline model is the simplest reference model used at the beginning of ML project. That means a baseline model is defined as the simplest prediction method created at the start of a machine learning project. It usually requires minimal computation, little tuning, and no complex feature transformations. The purpose of this model is not to achieve high accuracy but to establish a basic level of performance that later models must exceed. This makes it an essential first step in structured model development, and then it provides a minimal performance benchmark for comparison. That means performance it provides a minimal comparisons how it is going to give us. The main function of the baseline model is to provide a minimum benchmark score such as accuracy, error rate, or loss values. This benchmark becomes the standard against which all future models are compared. If a new model does not perform better than this minimal level, it indicates that the model is ineffective and needs improvement. Thus, the baseline helps quantify whether progress is actually being made during experimentation. Next, any trained model must perform better than the base model to be useful. That means for a machine learning model to be considered useful, it must outperform the baseline model. If a complex algorithm produces results equal to or worse than the baseline, it suggests that the model is not learning meaningful patterns from the data. This situation may occur due to poor feature selection, insufficient data quality, or incorrect model design. Therefore, beating the baseline is the first validation step before claiming model a success. Next point is it helps determine whether the model is actually learning patterns from the data. That means a baseline model helps verify whether the trained model is truly extracting knowledge from the dataset or simply making predictions that resembles random guesses or trivial rules. When the trained model shows a clear improvement over the baseline, it indicates that meaningful relationship between input and outputs are being captured. This confirmation is important before investing time in further tuning or a deployment. Next, why do we need a baseline models? Evaluation metrics alone do not indicate model quality. That means metrics such as accuracy, precision, recall, or loss values may appear impressive, but without a baseline, they do not reveal whether the model is genuinely good or not. For example, an accuracy of 85% might look strong, but if a simple baseline already achieves 83 percentage, the improvement is very small. That is 85 minus 82, 85 minus 83, only 2% percentage. The improvement is very small. Hence, the metrics only become meaningful when interpreted relative to a baseline reference. Next, a baseline gives context to accuracy, loss, or error values. That means baseline models provide context by showing what level of performance can be achieved without complex learning. This allows researchers to judge whether the improvements are significant or negligible. With this context, evaluation metrics become easier to interpret, helping in making better decisions about model design and tuning. And it prevents misleading conclusions from the complex models. Without a baseline, researchers may assume that a complex neural network is effective simply because it produces high accuracy. However, that accuracy might be achievable even with a simple rule-based system. Baseline models prevent such misleading conclusions by ensuring that any claimed improvement is real and not just an artifact of dataset distribution. Next, it helps verify whether machine learning is necessary for problem. That means in some real world problems, simple business rules or statistical methods may perform almost as well as complex machine learning models. A baseline helps determine whether advanced ML techniques are actually required. If the baseline already performs sufficiently well, it may not be worth investing in expensive model development and deployment. Next, a simple example of baseline model. Suppose we build a spam detection system. Data set contains a 70 percentage of non-spam mail. Consider a practical scenario where we are designing a machine learning system to classify emails as spam or not spam. This example helps illustrate how baseline models functions in real world classification problem and before building complex algorithms. For example, data set contains 70 percentage of non-spam emails. Assume that in our data set, 70 percentage of emails are legitimate and only 30 percentage are spam. This imbalance is common in real world data and strongly affect how evaluation metrics should be interpreted. Next, a simple predictor that always outputs a non-spam. That means if we create a trivial predictor that labels every email as non-spam, it will automatically be correct 70 percentage of the time. This model does not learn anything from the data, yet it still achieves relatively high accuracy because of imbalance. Next, this becomes a baseline of accuracy. The 70 percentage of accuracy obtained from this trivial predictor becomes the baseline score. It represents the minimum performance level any intelligent model must beat in order to be considered useful. Any ML model must perform above this value to be meaningful. If our trained machine learning model only achieves 72 percentage or 70 percentage accuracy, the improvement over baseline is very small. This suggests that the model needs better features, more data, or improved tuning. Only when the model significantly exceeds the baseline can we can conclude that it is learning useful patterns and it worth deploying. And so these are all the characteristics of baseline model. It is very simple and fast to build. It required minimum computations and it is easy to interpret and it is used as a reference point, not final solution. It will help us to identify data sets difficulty. And when baseline models are used, at the start of the model development during feature engineering experiments, when it will be used during feature engineering experiments while comparing multiple algorithms and before deploying the final models. The most important in the model evaluations are baseline models helps in measuring real improvement of trained model. It will detect weak data sets or noisy features, and it will guide further model tuning, and it will decide whether the complex models are justified or not. So these are all the things. And what is the takeaway? We are going to take it from this the baseline model is equal to starting point of ML modeling. It provides minimum acceptable performance. It will help interpret evaluation metrics correctly, and it is essential step before building the complex model. So coming into the overall the picture of this diagram. This diagram illustrates the complete workflow of how baseline model is used in machine learning model evaluation. At the top, here this is the top, the process begins with the data set, which represents raw data collected for solving a prediction problem. This data set cannot be used directly. So what we should do is, so first passes through the data preparation stage. So here the pre-processing we are calling it as cleaning or the feature selection. So the data set cannot be used directly, so it will be passing through the data preparation stage where cleaning and pre-processing and feature extractions are performed. This step ensures that the data becomes suitable for modeling. After preparation, the next step is building the baseline model, which is a simple predictor used as reference point. The diagram shows a typical baseline approaches such as predicting the majority class, predicting the mean value, or making a random guess. These methods do not involve complex learning but help establish a minimum expected performance level. The output of this step is baseline performance measured using metrics like accuracy, loss, error, or loss. This value becomes the benchmark against which all feature models will be compared. Here. So here, next year, trained machine learning. Here we have the trained machine learning or deep learning model is developed using more sophisticated algorithms. This model attempts to learn patterns from the data and produce better predictions than the baseline. So finally, the diagram shows that the comparison stage. We have the comparison stage. Here we have got a beautiful point. If the trained model performs better than the baseline model, trained model performs greater than the baseline, better than the baseline model. It indicates good learning and suggests that model is useful. If the trained model performs equal or less than worse than the baseline, if it signals that the model needs improvement, the possibility due to weak features, poor data quality, or improper training. Overall, what the diagram says that it emphasizes that a baseline model acts as the starting benchmark, and the success of any advanced model is judged by how much it improves overall over this baseline. Hope everyone understood about the baseline model. So here simply to say we have to fix one baseline before going for the evaluation. The remaining things we'll discuss in the next class, next lecture. Thank you.